Welcome back to the channel and welcome to another video on feature selection approaches. In this video we'll be discussing quasi-constant features. Quasi-constant features are another group of features or variables that are easy targets in the feature elimination process. Now while they don't show the same value for all the observations in a variable, they show the same value for majority of the observations, and just like their constant counterparts, they provide little if any helpful information to a machine learning model. However, we can have exceptions sometimes, so you would have to be careful in your personal applications. I'm going to show you two different approaches we can adopt in eliminating quasi-constant features using the same dataset we used in the previous video on constant features. We can use the variance threshold module from scikit-learn, or we can just code the procedure manually ourselves. But the benefit of using the coding approach is we can apply it to both numerical and categorical variables. Now, let's explore both approaches by starting with the variance threshold approach. As usual, the first thing we do is import all our dependencies. The next thing we're going to do is load our dataset, and it's going to be the same dataset from the last video. We can print out the shape of the dataset just to confirm that it's been loaded properly. As usual, we have 50,000 rows and 301 columns from the dataset. Let's now separate the predictors from the labels so we can split the dataset. And now we can go ahead and run train test split on the dataset. We have opted for a test size of 30%, so that means 30% of the original dataset is going to be allocated to the test set, and 70% of the original dataset is going to be randomly allocated to the training set. Now, before we go ahead and remove quasi-constant features, it won't hurt to remove constant features first and get them out of the way. And since our variables are all numerical, we can just use the standard deviation approach we learned in the previous video. Essentially, just to recap, what we have done here is iterated through the training set, the columns of the training set, and we have selected columns that have a standard deviation of 0. Because like we learned in the previous video, constant features have a variance and subsequently a standard deviation of 0, because all the values in the variables are equal. They're just one value. We can confirm whether or not our operation was successful by grabbing the number of constant features that were identified from the dataset. So we can confirm we have 34 features with constant values in a dataset, and this number tallies with the same number of constant features we discovered in the dataset in the previous video. So we can agree that our operation to remove constant features was carried out correctly. Let's go ahead and drop these features from the dataset. Now that we have carried out the drop operation in place, we can confirm from the updated shape of the training set and the test set whether or not the features have been dropped. So, as we can confirm on the screen, we have a reduction in the number of predictor variables from 300 to 266. Now that constant features have been removed, we can now go ahead and use variance threshold from scikit-learn to remove quasi-constant features. We won't set our variance to 0 this time, but we'll use a low enough threshold So remove features that have quasi-constant values. And for this operation, we'll select a variance threshold of 0.01. The next thing we're going to do is run the fit operation on the training set to find the features with low variance. Let's now run the get support method and grab the number of retained features. We can see that from 266 features, 215 features were retained. That should leave 51 features. Let's go ahead and confirm that. And we can actually confirm that the dataset had 51 quasi-constant features. So there are 51 variables in the dataset that predominantly show just one value. And it won't hurt to see what those variables are. So let's go ahead and print out our quasi-constant features. Again, because this is a toy dataset and it's not a real life dataset, we have decided to adopt arbitrary naming for the columns. But in any case, what you have on your screen is a list of all the features with quasi-constant values in the dataset. Now what we can do here is select any random quasi-constant variable and see what percentage of observations show each of the different values of the variables. Let's select variable 67, for instance. Now what this code cell right here is attempting to do is grabbing the value counts of all the unique values in variable 67 and then dividing it by the sum of the rows in the dataset, so we can get percentages for each of the unique values in the variable. So while the variable might not have constant features, we can tell there is a value in the variable that accounts for at least 99% of all values of all rows in the dataset. Since the goal is elimination of these quasi-constant features, let's go ahead and eliminate them from the dataset. As usual, we'll grab the variable names because the transform operation returns a numpy array and not a data frame. So let's grab the names of the variables we hope to preserve. Now that we have the names of the retained features, we can go ahead and transform the dataset. Let's print out the shape of both datasets to confirm that the operation was indeed successful. And there you have it. We can now go ahead and put the data frame back together. So with that done, we are now down to 215 variables after controlling for both constant and quasi-constant variables. We can now try a second approach, which is basically just coding the elimination ourselves. As usual, we will separate our train and test sets. Just like before, our test size is 30%. We will now iterate through the columns of the training set and identify the constant features first with the standard deviation approach. We can go ahead now and drop the identified constant features. Let's confirm that the shape of the data sets have indeed been updated. We're now down to 266 features from 300 initial features. Now we are ready to eliminate quasi-constant features. Let's start by creating an empty list that will store the quasi-constant features we intend to draw from the list. At this point, I need to explain the logic of the code we intend to run here. Essentially, we'll be running a for loop and iterating over the features of the training set, and for each of those features, we will rank the unique values by their percentage amounts and store the percentage amount of the most predominant value of the feature in a variable. If the percentage amount is larger than 99.8%, which is our threshold, we will append that feature to the list we created earlier. So let's write the code and run it. Now let's see how many quasi-constant features were returned from that operation. Notice that this second approach is a lot more aggressive compared to the variance threshold approach we tried earlier, because we have found 57 more quasi-constant features than we initially did with the variance threshold approach. Now we can go ahead and drop the quasi-constant features. We are now down to roughly half the size of the original feature space we started the elimination process with. Now just a little side note here. While a zero variance threshold is typically set in stone for constant features, the quasi-constant threshold is typically arbitrary and determined by the user, as we can already see from the different outcomes we had from the two approaches. So that'll be all for this video on quasi-constant features and how to eliminate them. I'll see you in the next video.